In lesson 11.4, we're going to be talking about hypothesis testing for two population proportions. Everything that we've done so far in Chapter 11 has been about population means. So we've been comparing the two population means, or we did a paired difference. That's what we saw in 11.3. Population proportions are quite a bit different, and so we're going to be pretty narrow in our focus. Primarily, the primary thing is that it's going to be binomial distributions. There are additional statistics tests you can run if you have more than two options, but for our purposes for this class, it's going to be a binomial. So our restrictions is we have simple random samples. They have to be independent. Has to be a binomial distribution, so independent trials, and there's only two possible outcomes. Probabilities are p and 1 minus p. And then the sample sizes are large enough that n1 times p hat 1 is at least 5, and n1 times 1 minus p hat 1 is at least 5, and the same thing for population 2. That should look really familiar for when we did the one sample population proportion hypothesis testing. It's lots of words. Also a reminder that the null has to have the equality sign in it. So we can write it like this, which is what your book does primarily with the subtraction, or we can write it as P1 is greater or equal to P2, and this one would be less than P2. This second way is going to be more common for us doing this problem because that's the way the calculator language tends to work. But this other one's helpful, but it's very similar to what we've been doing with means. Now, we can always pool the data from both samples to give a weighted estimate of the common population proportion. That's denoted P bar. That's something you're going to see in the formula. So if you need to calculate P bar, it's x1 plus x2 over n1 plus n2. And this is the fantastic test statistic. We will do one of these by hand, but we have the p hat 1 minus p hat 2, so those are the proportions from your sample proportions. The p1 minus p2, that comes from the null hypothesis, and then the p bar, we just talked about how to calculate that. We can use rejection regions if we're doing it by hand, so looking up things on the table, or we can use the TI. So we will do one of these entirely by hand, and then we'll do another one where we just put it into the calculator. Generally, we're just going to go with the calculator, but like always, you get to see one by hand because it's lots of fun. So we're going to start with the mayor. The chief of staff thinks that a local newspaper article has changed the way the community thinks about the mayor. So to test this theory, he finds a poll of the mayor's approval rating that was taken before the article came out and then compares it to the approval rating after the article. Before the article ran, 480 out of a simple random sample of 120 voters thought the mayor was trustworthy. I'm going to label these things as we go. So our before is going to be population 1. So population 1 is before the article. And our population 2 is after. So we're going to call this 480 X1 and 1200 is N1. After the article, 550, so that's going to be X2 out of 1180 N2, thought he was trustworthy. Based on these data, use a 5% level of significance to test the chief of staff's claim that the mayor's approval rating has increased. All right, so let's start writing some stuff down. The first thing we need is our null and alternative hypothesis. Since we've already established what our population 1 and 2 are. So the chief of staff is claiming that the approval rating has increased, that the after is greater. So he is saying, look, before the proportion of people who thought the mayor was doing a great job, the mayor, right? Yeah, okay. After the article came out, the approval rating was higher. There's going to be an announcement.
Riley Supel, if you are in the building, please come to the middle school office. Riley Supel, please come to the middle school office.
As a side note, why do middle school kids not know where to go? Anyway, The answer is go home. It's after school. There's our null hypothesis. Okay? All right, or you can write it with the subtraction. You can say P1 minus P2 is greater than or equal to 0. P1 minus P2 is less than 0. Either way. All right, we are running a z-test. Population proportions are always, proportion tests are always z distributions. Distribution at our alpha level is 0.05. All right, and now we need to calculate our test statistic. So this is where we're using that big fancy formula on the other side. So we need p hat 1 minus p hat 2. So p hat 1 is going to be that x1 over n1, so 480 out of 1200. Minus p hat 2 is going to be 550 out of, what was that, 1180? Minus, and then we have the P1 minus P2. That comes from the null hypothesis, so that's 0, just that whole thing is 0. Over, and then a square root, right? Square root. And this is where we need the P bar. So I'm going to do that just over here on the side. We need to calculate P bar. Remember that was x1 plus x2 over n1 plus n2. And this is basically being able to pool this data from the two populations. So that's going to be 480 plus 550 over, I think, 1200 plus, why can't I remember this number, 1180. And when we do that, we get a decimal. I'm going to use all 6 decimal points because I need it in future calculations right here. So 0.432773. And then we have 1 minus 0.432773. And then what else is under here? The rest of the formula is 1 over n1, which was 1200, plus 1 over n2. And that's still all under the square root. Yep. So that's big and fun and exciting. You're going to put that all into your calculator, and we get negative 3.25. Okay. So that's our z-score. Now, how much space do I have? Oh, I got enough space. Now that we know that, we're going to use rejection regions. So this is a left-tailed test. Okay. So we're going to look up the critical value for z. We're going to look that up. You can look up the critical value for z on the table, or the other thing we can do is we can say that this is negative 3.25, and our p-value is going to be this shaded region. Okay. So we can look that up on the table, area to the left of negative 3.25. You can also use your calculator at this point. And we get 0.0006. Did I get all the zeros right? Yep, 0.6. That is clearly less than our alpha, so we are going to reject. Our decision is to reject the null hypothesis. So when we reject the null hypothesis, I'm not going to write this sentence down, but remember you need to interpret this, use words to write a sentence and interpret this. My board is slow in writing, so I'm not going to. But we're going to say something like, at the 0.05 level of significance, the data supports that the mayor's approval rating has gone up. So that's how we would interpret this. On the next example, I will show you how to do this entire thing in the calculator.